Okay, the last thing in 8.4. So we're talking about standard deviation and all the different types, right? There's the population standard deviation, with you have one variable, the sample standard deviation, frequency tables, population sample, and then probability tables. The last thing is that special binomial case. And the special binomial case is always the one where you're going to have a formula, right? You have the Bernoulli's formula to solve for probability. You have the formula to find the expected mean, and you're going to have the formula for the binomial variance and the formula for the binomial standard deviation. So remember, these are if we have a case where there's only two possibilities, right? We have the binomial case. There's a positive outcome that we're looking for, and it doesn't necessarily have to be positive success. And then the complement of that. It can't happen. There's only two things. It either happens or it doesn't happen. And that's it. And remember, we can find an n, which represents the total number of tries, is my sample space. P is the probability of succeeding. Q is the failure, which is the complement of P. When we have the binomial case, again, it's based on probabilities, right? Binomial probabilities, right? Probability of success, probability of failure. And so it is the sigma squared when I'm looking for the variance. And so it's just the n times P times Q. Right? So the variance is taking those three numbers, number of tries, probability of success, times probability of failure, and that gives me my variance. The standard deviation then remembers the square root of the variance, which in this case would be the square root of n times P times Q. And these formulas you memorize. You can't plug them into the calculator. There's no binomial key for this in the calculator. You just have to know this formula. So write it down, have it with you, make sure you remember. If it's a binomial type, there's a formula involved. Alright, binomial type, there's a formula involved. Alright, there's three formulas. The Bernoulli's formula, which finds the probability of a certain event happening or not happening. There's the variance, and now there's the standard deviation formula. Oh, and there's the expected value. I forgot about the expected value. Remember the expected value, which is my expected V, was n times P. So there's four formulas. So looking at these examples, alright, suppose that we have a 100-question multiple choice test. Each question has 5 possible responses. Suppose the student guesses, find the random variable x. Okay, we found the expected value of this. We want to find the standard deviation. It is a binomial. X counts the number of questions guessed correctly. Right? There's only one thing you can do when you're guessing on questions, right? You're either going to get it right or you're going to get it wrong. That's the two possibilities. And so it is a binomial case. They're guessing on 100 questions. So they're trying 100 times. Probability of success, well, there were 5 choices on each question. One of them's the correct choice, so 1/5, which is 0.2. The probability of failure, well, that means there were 4 wrong choices out of 5. 0.8. And there's the 3 parts that I need. If you remember from before, the expected mean, which was n times p, which was 100 times our 0.2 we found before, was 20. So on average, we would expect students to guess 20 out of 100 questions right. How much will we deviate by that? So most people should guess between what values? Well, that's what the standard deviation is. So the standard deviation, which is the sigma, square root of n times p times q, not times another p, which would be in this case 100 times our 20% times our 80%, which comes out, that's 16, so 4. So the standard deviation is 4, and so we would, on average, based on probability, guess 20 questions and deviate on average by 4. So the plus 1. So most people would score 20 plus or minus 4. So they'd score between 16 to 24. Alright, so if you're actually doing this, and if you have a bunch of people doing this, most people should guess, if they're just randomly guessing on this type of test, should guess somewhere between 16 and 24. The majority. Now, there will be a few outliers that will land outside of 16 and land outside of 24, but those should be rarer. Most of the time, they'll land between 16 and 24. Right, next example. Alright, a poll conducted in the U.S. World News reported that 84% of college students believe they need to cheat to get ahead in the world today. 500 college students are surveyed. How many would you expect to say they need to cheat to get ahead in the world today? What is the standard deviation? And then interpret it. Alright, so I actually need to find my expected value and find my standard deviation. Now, first thing, again, with these, is you have to recognize it's the binomial case. Either students have to feel like they need to cheat, or they don't, right? Those are the two options. And so X would be the students who feel they need to cheat to get ahead. Just going to put cheat. N, we're surveying 500. Probability that they land in that category was 84. Probability they don't feel that way would be 84 minus 1, which would be 0.16. Right, the expected value, how many would we expect? What would be our expected average? Well, that would be the N times P, so I take my 500 times the probability, and so it would be 84% of 500 is what we would expect, and so that comes out 240. Not 240. 420, get it out right. 420 would be my expected value. The standard deviation, which is the sigma n times p times q, and so our 500 times the 0.84 times the 0.16, which that comes out, I'm just going to type it in all in one shot, 8.197, and so I'm just going to round to 8 students since I'm talking students, just to make it a little easier to interpret. Alright, now the interpret part. What does that mean? So it means, on average, we expect, based on our probabilities, 420 out of 500 college students to feel they need to cheat to get ahead in the world today, with a deviation of 8. So I mean the plus minus is on 8. So the range would be anywhere we would expect. So if we actually did the survey of 500 students, most of the time it should land between 420 plus 8, 420 minus 8, and so it would be 412 to 428. We would expect somewhere between 412 students to 400, again, that would be our expectation. Based on probability, that's where we would expect it to land. Right, now, if we actually did it, we may get people to land outside of that, but those should be rarer cases. Most of the time, if we polled 500 students, based on the statistics, it should be somewhere between 412 to 428, and if we did it a bunch of times, it should average out to 420. Right, that's our expectation. Alright, so binomials, you have to remember the formula. And so, try on your own. I basically did one of each type. Alright, so again, this would be a 1 list, this would be a 2 list, and this would be a binomial type. Right, and so those are yours to try on your own. Alright, so that finishes up 8.4, which again, 8.4 is not too bad, but there's a lot of little details you have to keep track of so that you don't accidentally type something wrong into your calculator and you don't accidentally read the wrong answer out. So you just have to be very diligent when you're doing